Welcome back to Golang for Devs. Today I'm covering everything you need to know about maps, which are the key value data structure in Go. So let's get to it. Like strings and slices, maps are also reference types, which means that they point to some underlying data and don't store the data directly. So when you pass a map to a function, if you modify the map inside that function, the original value will be modified as well. Okay, you can create maps in 3 different ways. The first is using var syntax like this. The type in the square brackets is the type of the key, and the type outside the square brackets is the type of the values in the map. And an important point is that map keys must be of a comparable type. So usually that means using a string or a numeric value like an int, but you can't use something like a slice as a key. Then the shorthand syntax also works. And lastly, you can use the built-in make function to create an empty map. The benefit of using a make function is that you can provide a capacity hint, which can help with allocation performance by telling Go approximately how large your map is going to be. Unlike when you use make with slices, this value is only a hint, so the Go runtime takes it into consideration, but there aren't any guarantees. The 0 value for a map is nil. And it's important to know that nil maps can be read from safely, but if you try to write to it, Go will panic. For that reason, it's typically considered best practice to use an empty map when you can instead of a nil map. This will prevent accidental panics from writes. Okay, next up is how you access and modify maps in Go. So if we have a map, you can access a value from the map using simple square bracket notation that you would see in any other language. Then you can update values in the map using similar square bracket notation. And the same syntax is used to add new values to a map. One nuance to understand here is how to check if a key is already present in a map. Unlike languages like JavaScript, if you try to access a missing key in a map, you won't get something like undefined or nil. Instead, Go returns the 0 type of the value type for the map. The trick is that you can't distinguish between a missing key and the value being purposefully set to the 0 value. So here, if I set apple to 0 and then access it, I will get a value of 0 back. But if I try to access a missing key, I'll also get a 0. To get around this, you can use the second value that accessing a map in Go returns. So if I try to access apple, the OK value will be true. And if I try to do the same thing for kiwi, the OK value will be false because that key doesn't exist in the map. All right, next up is deleting key value pairs. The first way is to use the built-in delete function. And you pass the name of your map in and the key you want to delete. And then the second way is to delete all the keys in the map using the clear function. Pretty straightforward. Next, you can get the number of keys in the map using the built-in length function. So it's the exact same thing as strings and slices. And if you don't know what those are, you can check out my previous videos in this series. And the last basic thing you can do with maps is iterate over them. And you do this using a for range loop, which gives you the key and the value. One thing that is incredibly important to know about iterating over maps is that the key value pairs you get will always be in a randomized order. And the Go runtime does this purposefully so you don't rely on soft ordering guarantees in maps. And it's also super important to like and subscribe if you're finding this helpful. All right, that's all the basic operations you can do with maps. But the Go standard library has a maps package that gives additional functionality. And I'll cover most of it here, but I'll leave a link to the docs in the description so you can give it a read through. The first function we'll go over is clone, which is used to make a shallow copy of a map. A shallow copy means that if the values in the map are a reference type, like a slice, then only the reference is copied. The actual underlying array for that slice wouldn't be copied. So if I cloned a map that had slice values and then I modified one of the slice values in the new map, it would also be updated on the old map. In contrast, for value types like ints, the actual value is copied, so there's no conflicts. There's also a copy function which copies the values from one map into another. So you can merge maps with that. So you have to pre-allocate the destination map, and then you can call maps.Copy destination and your source map. And it's worth noting that any duplicate keys in the destination map will be overwritten by what's in the source map. So the final value for the DST map here would be 1 for Apple. Okay, next up is filtering maps. And you can do it using the DeleteFunc function in the maps package. So this function accepts the map you want to filter, and then a custom function that accepts the key and value as arguments and returns a Boolean. And if this function returns true, then the corresponding key value pair will be deleted from the map. So in this case, it would delete the banana key. Okay, next up is comparing maps. Similar to slices, you can't use comparison operators like equals equals to compare maps. So the maps package gives you a couple functions to do it. The first is maps.Equal, and it returns true if all of the keys and values match. And the next one is maps.EqualFunc, which lets you pass in the maps and then accepts a custom function that lets you manually compare the values key by key in each map. The rest of the functions in the maps package deal with iterators and sequences, which is a whole other separate topic in Go that I'll cover in a future video. The TLDR is that an iterator is just a function that accepts a yield function and then calls the yield function with every value in a series. And a sequence is just the sequence of values that are passed into the yield function. When working with maps, these are mostly only useful for compatibility with other packages in the standard library. To cover the functions briefly here, the all function returns an iterator over all the key value pairs in the map. The collect function lets you take an iterator and turn it into a map. The insert function will insert values from an iterator into an existing map. The keys function gives you an iterator that iterates over all the keys in the map. And you can use the slices package to convert that into a slice. And then the values function does the exact same thing for the values in the map. All right, the last key point to cover about maps is that they are not concurrency safe. So if you write to a map while another Go routine is either reading or writing from that map, then the program will panic. And I'll cover Go routines and concurrency in a future video. But the TLDR is if you're working with maps in two different Go routines, you should always use something like sync.mutex from the sync package in the standard library to allow for safe concurrency. And that is literally everything you need to know about maps in Go. If you want to see any of the code or diagrams from the video, the link to the repository is in the description. Thanks for watching, and as always, keep building, keep breathing, and I'll see you next time. Peace out.